Hello, what's up? We are going to look at another question on secular measure. As I said in the beginning, we are solving easy questions. This is 2018 variant 11 winter. It's an IG paper. All right, so the first question for today. The diagram shows a circle with center O, radius R. The minor arc is AB, and the angle AOB is theta radians. Now, the area of the minor sector is 48 centimeter square. Okay. Now show that theta is equal to 96 on r squared. All right. So to start with, we have been given the area. Let me use my normal blue pen. Area of sector AB. Sorry, AOB is given by 48. And we know that the area of a sector is half r squared theta. So if we come and make theta the subject, 2 times 48, you get 96 divided by r squared. So there you have it. That's the first one. Given that the minor arc AB is 12 centimeters, find the value of r in theta. Okay, so now the length of the minor arc AB. Always label your the part of the circle you are talking about. So rho is equal to 12. That's the first. Can I call this one? I can call this one equation 1. Okay. But don't forget that you said here that theta is equal to 96 on r squared. Okay. So now, can this one be written as, r times r is the same as r squared? Okay. Yes. Can you see something? Is there a connection between equation 1 and equation 2? Yeah, there is. They both have rho in common. So put 1 into 2. So that'll give you 12 is equal to 96 on r. So if I make r the subject, I'll get 96 on 12, which is the same as 8. Okay, then let me do something quickly. Okay. Okay, so I have more space to work with. Okay, now from equation 1, we can now say that theta is equal to 12 over r. Okay, your r, mind your r is 8, so this should give us 3 over 2, which is the same as 1.5 radians. All right, and bring my centimeters here. Using your r and theta, find the area of the shaded region. Okay, so let's go and look at the region they're talking about. The region they're talking about is a segment. You can see it for yourself. This is a segment, okay? So, area of segment is given by half r squared into brackets theta minus sine theta. So I'm going to get half your r, your r is 8 squared. Um, Theta is what? 1.5. So let's solve this one and see what you get. If you solve this, you get 16.1 centimeter squared. Don't forget to bring your units, very, very important. Okay, so let's carry on. You'll come to this question later. It's a proof question. I'll do a special video on that one. Let's tackle the easy ones first. Okay, so let's look at this question. Number five. Mm, it looks a little easy. So this is 2023, October, November, variant 2-1. Okay, let's look at it. Now find the perimeter. You see, before you start tackling the questions, one of the important things to do is to try and understand what the question demands, what they are trying to ask you to find. Make sure that you understand. Okay, so read the question very carefully. Okay, so I believe you have figured something out. Now let's see. So the center is has radius. Okay, the radius is 6. AB is tangent to the circle. Okay, so if that's the case, can I connect this side? Yes. Let's see what will happen. So if AB is tangent to the circle, that means that this side is 90 degrees. If you want to know why, you can refer to my first video on concepts. The radius always meets the tangent at 90 degrees. Point C lies on the circle such that A will see is a straight line. AB is 8. Okay, so this side will be 6. So basically I have a right angle triangle here. Can you see? All right, so let's find the length of AO. So if you are using the Pythagoras theorem, AO squared is equal to A squared plus C squared. Yes. Let's find the square root of both sides and see. So that should give you 10. That should give us 10. So we know for sure that this side is 10. From A to O is 10. Okay. Um. All right. So I have this. I have that. I can find. So the only thing that's left is the length of the arc, BC. Before I can do that, I have to find the angle here. Okay. So what do you think? How can I find the angle there? Mind you, you can also find the angle at this side. Okay, because the right angle triangle. So basically, you have something like this. I'm just turning it upside down so you can see clearly. So here's O, um, here's B, here's A. So let's say the angle here is theta. Or let me make it alpha. We like using theta too much. Today I'm using alpha. Okay, AB is 8, BO is 6. So we can clearly see that um, tan alpha will be 6 on 8. So come and find tan inverse of this and let's see. 6 on 8. Oh, no, it's supposed to be 8 on 6. 8 on 6. Okay. My bad. 8 on 6. Let's try it and see. Okay. You could have left your answer in three significant figures. Radians. So I know the angle here. Right now, you know the angle here to be 0.923. Okay. So now we can find the angle here. Very easy. So the angle there is going to be, can you guess? This way I'll need my calculator by my side. So the angle there is going to be, make sure your calculator is in radians. You just subtract it from pi. Okay. So the angle here is going to be, because it's an angle on a straight line. Don't forget. So you got what? 2.214. Can I see? 1.5. Okay. can we say that angle BOC is equal to pi minus, as much as possible, try and show working of what you are doing. Even if you know, make sure you write it down. Don't assume that the examiner will understand what you have done. And we also award marks for each step, so don't forget to show working, okay? Yeah. So you have found the angle in radians. Now we can easily find the length of this arc. Arc. Length of minor arc. BC is simply rho, which is the same as 6 times, what's your angle? 2.215. Let's multiply and see. Okay, I'm getting 13 point what? Um, 13.3. Okay, I've rounded it to 3 SF, three significant figures. Okay, so right now I know the length of what? BC. So we are good. We are good to find the perimeter of the figure. Perimeter of shaded region. So you're going to have 6 6 plus 13.3 plus 8 plus 10. Okay, let's follow the same thing. 6 plus 13.3 plus 8 plus 10. So when we add this, we are going to get 37.3. Okay, so we are done with the perimeter. Perimeter, okay. Well done. Let's see. Let's look at the new challenge. Is there a B? Okay, there's B. Now the B says that find the area of the shaded region. Area of shaded region. Let me cut this diagram here so that I can easily refer to it. Okay. Find the area of the shaded region. So to start with, I can find the area of the right angle triangle. Area of triangle AOB. You know, this is the same as half times base times height. What is my base? That's AB. So it's 8. What is my height? My height is 6. It's the same as the radius. Okay. This should give me 24. Now we come to area of the minor sector. Area of, that's this side. Area of minor sector. Remember I said label your dimension, whatever you find, make sure you label it. Sector BOC. And it's a minor sector. Be very specific because you also have a major sector. So this is going to be half. What is your R? Your R is 6. Okay. What's the angle? 2.215. So now let's check. Half times 36 times 2.215. Okay. Moment of truth. Bang. You get 39 point. Come again? What they say? 39.9. Okay, 39.9. Let me write my theory properly. Okay, so that's it. But we are not done. We are asking for the shaded area. So shaded area is going to be 24 plus 39.9, which will give us 36.9 cm squared. So that's it. All right, so I will end here today. Make sure you follow me for more content. If you enjoyed this video, don't forget to share it with a friend.